3-2, rate of change and slope. So first off, what do they mean by rate of change? Rate of change is how a quantity is changing with respect to the change in another quantity. So in other words, how does it go from, on a graph, how does it go from one point to another? If x is the independent variable and y is the dependent variable, then the rate of change is your change in your y divided by your change in your x. And we have some formulas down here. Here's actually the slope formula, y2 minus y1 divided by x2 minus x1. That's your change in your y divided by your change in your x. You also may remember rise over run. Here's the change in y over change in x. And then the slope is just your m in the formula y equals mx plus b. So find the rate of change. Find the rate of change of the function by using 2 points from the table. So I pick any 2 points. It doesn't matter which 2 points. I typically use the smaller ones. So if I use these 2 points here, I'm going to use the formula y2 minus y1 divided by x2 minus x1. So the y2 I'm going to use as 24 minus 12 divided by, and here I have to remember to partner them up. If I chose 24 first, I got to use 4 first as my x2 minus 2. So it'll give us 12 divided by 2. 12 divided by 2 will give us 6. So we would have a slope of 6. And that would just mean 6 pancakes for each cup of flour. The dependent variable is in the numerator and the independent variable is in the denominator. In this example, the number of pancakes you make depends on the amount of flour you use. So that's how we had 6 pancakes for every cup of flour that we used. Next, find the rate of change in this table. Again, we just pick 2 points. I'm just going to pick the first 2 here. And I'm going to do 19.92 minus 15.77. We're going to divide that by 6 minus 4.75. So 19.292 minus 15.77 gives us 4.15. And then 6 minus 4.75 gives us 1.25. And if I take 4.15 divided by 1.25, I get an answer of 3.32. And if I put it as a fraction, I would get 83 over 25. But if we were to interpret what this means $3.32 would be the change in dollars per gallon. Next, the amount of money working X hours is shown in the table. Find the rate of change. So I'm going to take 93 minus 62, divide that by 12 minus 8. 93 minus 62 gives us 31. 12 divided by 8 is 4. So 31 divided by 4 gives us 7.75. So that would be $7.75 per hour. Next, the Jacksonville School budget every pay for the fundraising of the previous year. Find the rate of change for 2005-2010 and then describe its meaning in the context of the situation. So for this one, I'm going to take just these first 2 points. So I'm going to have 1675 minus 1350 divided by 2010 minus 2005. 1675 minus 1350 gives us 325 divided by 2010 minus 2005 is 5. So divide everything by 5 here. I get 65. So what does that mean? That means for each year, for the first 5 years, they increased by $65 per year. So this would mean $325 over 5 years. So that would make this a rate of $65 per year. So their budget was increased by $65 per year. Part B, find the rate of change for 2015, 2020, and describe its meaning in the context of the situation. So for the next 5 years, or not next 5, the last 5 years, we're going to do 1325 minus 1550 divided by 2020 minus 2015. So we have 1325 minus 1550 gives us a negative 225 divided by 5. This gives us negative $45. What does that mean? They had a change of $45 per year, so it went down. Budget decreased by $45 per year. Next, the graph shows the average ticket prices for the Miami Dolphins football team. Find the rate of change in ticket prices between 2009 and 2010. 2009 to 2010, we're talking about this point to this point. So we have 70.54 minus 66.74. Divide that by 10 minus 9. Give us 1. And then 70.50 minus 66.74 gives us 3.76. So we would say that the rate of change was $3.76. When going back, looking at it, I noticed I used the wrong number. It wasn't 70.50, it's 70.54, which would make this 3.80, $3.80. Part B, between which two years do the prices have the fastest rate of change? So for this one, we're just looking at one change more in a quicker time. So from 1 year to the next. That would actually be 2013 to 2014. And how do I know? Because this one is the biggest drop in price here in one year. So that would be the one that had fastest change. Now, if I were to do the math on here, I would have 65.16 minus 71.14 all over 2014 minus 2013. This will give us a negative 5.98. That's going to help us with this last part, which says part C, between which years is the rate of change negative. So we already know that 2013 to 2014 was a negative change. There was another one that was a negative change, and that is right here. So that would be 2010 to 2011. How did I know that from the graph? Because the line is going down. When the line goes down, you have a negative slope. That means there's a negative change. That means it dropped in price at that point. Next, city's temperature at various times on a given day is shown in the graph. Find the rate of change of the function between 10 a.m. and noon and describe its meaning in the context of the situation. So 10 a.m. till noon, So time since midnight. So 10 o'clock, 10 a.m. from midnight. So you got 12 to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is 10 hours. That's from this point right here to noon, which would be 12. So from here to here, we want to find the rate of change. So this would be, if I write the ordered pair, one would be 1060 and the other one would be 1265. So if I do 65 minus 60 divided by 12 minus 10, I'm left with 5 divided by 2, which will give us 2.5. That would be 2.5 degrees per hour. That it increased. So it increased by 2.5 degrees per hour. Next, rate of change, determine whether each function is linear. If it is, then state the rate of change. So you need to have a consistent slope involved with it. So we need to find the slope here. So I'm going to do first two. So I have -3 minus -5 divided by 8 minus 11. I have 2 over 3, so that's 2 over -3, so I have a -2/3. If I did the next one, I would have -1 minus -3 all over 5 minus 8, and I get 2 over -3. If I did the next two, this one would be 1 minus -1 divided by 2 minus 5, which will also give us 2 over -3. And the last one would be 3 minus 1 over -1 minus 2, which will give us 2 over -3. This one we have same slope for all of them, so this is linear. Next, just checking my x's here. I'm going to do a little bit different here. So this one's increasing by 7, increasing by 7, increasing by 7, increasing by 7. Here I'm adding 3, here I'm adding 2, here I'm adding 3, here I'm adding 2. Very quickly, let's do the slope for you. You notice that these aren't the same, as opposed to over here, this was adding 3, or subtracting 3, minus 3, minus 3, minus 3, and this was adding 2, and you had 2 over 3. This one, they're not the same, so this one would not, but if I want to just use the formula, I could do -1 minus -4 divided by 29 minus 22. I end up with 7 over 3, so 3/7. And then the next one I would have 1 minus -1 over 36 minus 29. That gives me 2 over 7. They're not the same. Next, you need to complete the table so that the function is linear. So you're going to use the information that they give us, fill in the blank. First thing I want to do is find out how is it changing. So this one is subtracting 3, subtracting 3. That means I got to subtract 3 here. -2 minus 3 is -5. Then here, I'm subtracting 7 each time. So if I subtract 7 here, that's going to give me 9. And if I add 7 to 16, that's going to give me 23. So now all these are the same. I would have a slope of changing my y is -7 divided by changing my x, which is -3, which will give us 7/3 as my slope. This next one here, subtracting 0.5, subtracting 0.5, subtracting 0.5. That means I have to add 0.5 to go up. This would be 11.5, and this will give us 12. Here, I have a negative 2.25, and I'm getting positive, so I'm adding. This would be a positive positive 1.25. It would be positive. It would be positive 3.25 because from negative 2.25 to 0 is 2.25. From 0 to 1 is 1, so 1 plus 2.25 gives us 3.25. So if I add 1 to that, that gives me 4.25. And if I add 3.25 to that, that gives me 7.5. Then add 3.25 gives you 10.75. Then add 3.25, 10.75 plus 3.25 gives us 14. And if we were to find the slope of this, this would be 3.25 divided by negative 0.5. So 3.25 divided by negative 0.5 gives us a slope of negative 6.5. Next, function is linear. For this one, we had to make that make them linear. Here, we just tested them out. So again, here I'm adding one, adding one, adding one, adding one. Here I'm adding two, adding two, adding two, adding two. So this is linear. And the slope would be 2. So 2 over 1, which is 2. Next one. This one is increasing. So 0.4 to 1.6 would be 1.2. And then this would be 1.2. This would be 1.2 and 1.2. So we're just adding. Over here, 3 to negative 3 would be a minus 6. I subtract 6. Here I subtract 7. Here I subtract 6. Since it's not the same on both x's and y's, no, this is not linear. Next, with dealing with the slope of a line, the slope of a line is the rate of change in the y-coordinates, the rise of the corresponding change in the x-coordinate, the run for points on the line. Slope is used to describe the steepness of a line. The greater the absolute value of the slope, the steeper the line is. So slope means rise over run. And here you see our formula again, y2 minus y1 divided by x2 minus x1. So the slope again, slope in the formula or in the equation y equals mx plus b, the m is your slope. The slope of a non-vertical line through any 2 points, x1, y1, and x2, y2 can be found as follows. Using the formula which we have used already. You can only use this formula for linear lines, not for non-linear. The slope of a line can be positive, negative, 0, or undefined. You can use the slope guy you see here. When the line is going up from left to right, you have a positive slope. When it's going down from left to right, you have a negative slope. When you have a vertical line, this is undefined. And when you have a horizontal line, the slope is 0. To use that to help you determine should you have a positive, negative, undefined, or a 0 slope. Another way of doing that is using the tree slope. Here, from left to right, positive, negative goes down from left to right, 0 slope is going straight across, and then the stump would be the undefined slope. So undefined means you just can't divide by 0. So anytime your x is, if you have a vertical line, it's going to be undefined. Slope of a line can show how a quantity changes over time. So when finding the slope of a line that represents a real world situation, is often referred to as rate of change. So when you think of rate of change, think of slope as well. So we need to find the slope of the line that passes through each of these points. These are going to be my 1s. These are going to be my 2s. So I'm going to take 7 minus 4 divided by 1 minus -3, and I'm left with 3 over 4, so a slope of 3/4. Next one, I have 1 minus 3 all over 4 minus a -1. I would get -2 over 5. Now let's just say you decide to switch them around. So maybe you did 3 first. 3 minus 1 divided by -1 minus 4. You would still get 2 over -5. Same slope, same signs. The answer would be the same. Just make sure whatever order pair you start with, you start the bottom the same way. Next, -5 minus a -5 all over -2 minus 4. So here I have 0 over -6. When the numerator is 0, that means the slope is 0. Here I'm going to choose -2 to go first. So -2 minus 4 divided by -3 minus -3. Here the denominator is 0, the numerator is 6. I have 6. I can't divide by 0, so this would be undefined. Next, determine the slope of a line passing through the given points. If the slope is undefined, write undefined. Write as a decimal if necessary. So I'm going to have 1 minus a -4 divided by 0 minus 5. I get 5 over -5, which gives me a slope of -1. Next, find the slope of a line points. So I'm going to have 1.8 minus a -2.4 divided by 4 minus a -3.2. So 1.8 minus a -2.4 gives us 4.2 divided by 4 minus a -3.2 gives us 7.2. 4.2 divided by 7.2 gives us the answer of 7/12. I would write it as a fraction. If you put it as a decimal, you're going to have to round it, which would be roughly 0.58. But 7/12 would be the best answer for that one. Next one, I have -2 minus 3.5 divided by 1.5 minus 0. This gives us a -5.5 over 1.5. This one I'm going to get my calculator out here so you can see how you can go from fraction to decimal. So I have -5.5 divided by 1.5 gives us 3.6 with the 6 repeating. Now if I hit the math button, go to number 1 fraction, and then hit enter, it changes my answer to a fraction, which would be -11/3. That would be our best answer, because you don't want to round it off, because then you change the slope a little bit. So -11/3. Next one, I have 6 minus 6 divided by -1 minus 3, which would give us 0 over -4, means we have a slope of 0. And our last one, we have -1 minus 9 divided by 4.5 minus 4.5. We have -10 on top and 0 on the bottom. This is undefined. We cannot find the slope because there is no slope, because we have a vertical line. Table 5, find the coordinates given the slope. So now we're going to have to find what are the coordinates. And you're just using the slope formula. So it says find the value of r so that the line passing through -4, 5, and 4r has a slope of 3/4. So if I use the formula y2 minus y1, divided by x2 minus x1. This has to equal the slope. Our slope is 3/4. And we're going to use this one as we'll use this one as our 2's and these as our 1. So now I have 5 minus, actually, no, I'm gonna put the variable first. So these would be 2's and these would be 1's. So I have r minus 5, divide that by 4 minus a negative 4. And the reason why I'm doing that is so that I can have my variable positive when I'm solving this. So if I simplify this, I have r minus 5 over 8. This has to equal 3/4. Then we can use cross products. So now I have 3r minus 15 equaling, or not 3r, we have a 4r minus 20 equaling 24. If I add 20 to both sides, I now have 4r equaling 44. Divide by 4, r should equal 11. Next one, find the value of r so that the line passes through -3r and 7, -6. And the slope has 2 2/5. This, I'm going to make that as 10, 11, 12, so 12/5. So I'm going to do r minus a -6 all over -3 minus 7. This is going to give us 12/5. So if I simplify this one, this is r plus 6 all over -10 equals 12/5. This one I'm going to do a little bit differently. If I multiply 5 times -2, that gives me -10. That means if I multiply 12 by -2, that's going to give me r plus 6 equaling a -24. Now I can just solve for r by subtracting 6, and I would have r equaling a -30. Now, if that was more confusing, you could still do the cross products. So if I were to do the cross products on this, I would have 5r plus 30 equaling -120. If I subtract 30, now I have 5r equaling a -150. Divide that by 5, I end up with a -30. Next, find the value of r so that the line passes through n -3 and r5 has a slope of -4. So I'm going to do, so r is my x now. So I'm going to have 5 minus -3 all over r minus 10. This has to equal a -4, and I'm going to make this over 1. Okay, so if I simplify this, I have 8 over r minus 10 equals -4 over 1. So if I multiply this times -2, that gives me 8. That means I multiply this by -2, and that's going to give me r minus 10. So r minus 10 would equal -2. If I add 10 to both sides, r would equal a +8. Or you can do cross products. Which this will give us 8 equaling -4r plus 40. Subtract 40. I would now have -32 equaling -4r. Divide by -4. R would equal 8. Next, what is the slope at Cape Hatteras? So we need to find the slope of this line here. So they're giving us our coordinates here. So I need -2700 minus -65 all over 125 minus 75. So a negative 2,700 minus a negative 65 gives us negative 2635 all over 125 minus 75 gives us 50. So when you have negative 2635 divided by 50, this gives us a negative 52.7. And let's go to example 6. It says, on a flight from Chicago, Illinois to Denver, Colorado, the typical cruising altitude of a passenger jet is approximately 38,000 feet. As the flight departs from O'Hare International Airport, the jet begins to ascend. At 4.3 miles away from the airport, the jet is at an altitude of 4,200 feet. The jet reaches an altitude of 36,700 feet at 167.5 miles away from the airport. Determine the slope of ascent of the flight, given that 5,280 feet equals 1 mile. Round your answer to the nearest thousandth. So this is going upwards. But first, we need to come up with our points. So we have at 4.3 miles from the airport at a height of altitude of 4,200 feet. So we have 4.3 and then 4,200. The other point would be 167.5 and 36,700. So there's a couple of ways of doing it. These are the points that they give us, but remember these are in miles and these are in feet. We need everything to be in feet. They want us to run to the nearest thousandth. So we could use these numbers and then convert everything to feet, or we can convert the miles to feet first. I think it might be easier to convert that to feet. So we're going to take the 4.3 miles and multiply that by 5,280, which will give us 22,704. And then we have 4,200. And the second one, we would do 167.5 times 5280. And that would give us 884 for 100. And then that's 36,700. Now we can use the formula. So we're going to I'm going to get my calculator out so it'll be a lot quicker and easier to do that. So I'm going to use parentheses and I'm going to do 36,700 minus 4,200 end parentheses, and then we're going to divide by the change in our x's, which is 884400 minus 22,704 end parentheses, hit enter. Just double check that I used the right numbers. 88. I used the wrong numbers, so let me edit what I had in here. So this would be 884400 minus 22,704. Then hit enter, and there we go. Nearest thousandth, that means 3 decimal places. So tenths, hundredths, thousandths. This 7, we need to round, but this 7 tells us to round the 7 up, so it'd be 0.038. That would be the slope, and this is ascent, which means it's a positive 0.038. That is our lesson today on rate of change and slope.